Hello, my name is Nadia Hetzel. I am the winemaker for Cypress Bend Vineyards, and I'm also the president of the North Carolina Muscadine Growers Association. Today, I'm going to be talking to you about the ideal harvest parameters for winemaking with muscadine. So we're going to start by preparing our samples. You would take a 100-berry sample per plot. In other words, if you have like a half acre of Noble, you'd take 100 berries from there, and maybe you just have a half acre of Magnolia, you'd take 100 berries from there as well. Or if you have, for instance, 25 acres of Carlos, you want to break those down into 5-acre sections and take a 100-berry sample from each of those areas. Now, the berries need to be randomly selected from all portions of the canopy. So that means basically going through there blindly as possible and sticking your hands into the canopy, pulling from the tops, the sides, near the trunk of the vine, and sampling without looking if you can. And I promise you there's no wasps up there whatsoever, because what happens is the human mind wants to pick the most beautiful berry if it sees it. So if you're looking at the canopy, you look in there, you're going to be like, oh, that's a pretty one, and grab it. And then you're not going to have a very good reflection of the fruit chemistry overall. So again, you also want to pick from the back portion of a cluster of grapes or a little, ball of grapes area, and also from the front, some hanging out in the sun. So just try to go through there and get them as randomly as you can. Also include those hard berries that are coming off of there, because you want to be able to see later on in your bag an accurate reflection of what you have out there in the vineyard. And don't worry about those hard berries later on. They're not going to alter your fruit chemistry, but it will tell you if maybe there's some kind of a problem with secondary growth or just issues, period, with ripening, that you may want to wait a little longer. So again, those berries aren't going to hurt your fruit chemistry, but don't try to press them out. Don't sit there and like hammer on them or whatever in order to get some of their juices out, because that will alter your fruit chemistry in a very negative way. So use clearly labeled plastic bags, obviously, and basically take your sample to the lab, press the juice out in the bags right there, just kind of massage those bags until you get a nice juicy extract going on there. And then what I usually do is just cut the tip of one side of the bag, the very tip, and just let the juice run out into some kind of container. And from there, if you want to filter that sample to get a highly accurate reading, which it's not always necessary, but some folks prefer to do that. Then what you would do is basically just take a small funnel and run that sample through the funnel with a piece of, say, a coffee filter cut to the right size. And once you run it through that coffee filter paper, it should get you a nice clear sample of juice, which is good for when you measure your TA. So we're going to measure our Brix, which is an indication of our sugar. We're going to measure our titratable acidity, and we're going to measure our pH. So why are we going to measure Brix, our titratable acidity, and pH? Well, first of all, we need to know our Brix, because that's the sugar content, and that's going to determine our later alcohol levels in our wine. And you want to make sure that you're reaching an alcohol level that is appropriate for wine. Say at least somewhere around 20 Brix would be a good mouthfeel indication. So what we need to do then is determine how much we have, then find a way to add more, because with muscadine, we always have Brix in the pretty low area of about, anywhere from maybe 12 to 15. And those obviously are going to give us very low alcohol levels. So we want to bump up our alcohol by adding sugar. So we also need to know the levels of our tartaric acid to determine ripeness. So that will give us an indication if our berries are not quite ripe yet, or they need to hang a little bit longer. Or for instance, if they're overripe, that will tell us that as well. So if you remove later on some of that tartaric acid, that'll kind of smooth things out. It's kind of tricky. So I've been on both sides of that spectrum. I worked in Texas for a while in a very hot climate. And that was a place because the tartaric acid would basically rapidly deteriorate. We would need to add tartaric acid quite a bit. So that tends to be the issue in a warmer climate. And then if you're in a cooler climate, working with cold climate varieties or cool climate varieties, you're probably going to wind up wanting to remove some of the tartaric acid. And you could do that with calcium carbonate or do a double salt deacidification even. So that's also why we need to know the pH for a number of factors. Not only is that kind of an indication of the tartaric level, the tartaric acid level, but it also has a lot to do with the wine stability later on. If that wine, in other words, is going to have microbial spoilage issues. It's also going to tell us how much sulfite we need to add, because we base our sulfite additions on our pH level. And it'll also give us a ripeness indication for sure, and give us a sense of flavor, or it'll give us I've heard actually that the lower the pH, the more you salivate, salivate when you drink wine. So it definitely has an impact on the flavor as well. Here are some of the tools we'll need to do our sample measurements. This is a refractometer. And basically what this gentleman did is up here in the front, he would have opened this flap and added several drops of juice to it, then closed the flap, and he'd look through it and he would see something like this. So I later noticed that I've used an Hetzel chart instead of a Brix chart. That's just the German sugar content measurement. And let's say if he added the sugar drops, this is at a neutral stand here, but if he added it and we got to like 95, that would make a nice Spätlese in Germany for sure. And it would have a decent amount of sugar for us there. So we'll be measuring in Brix and do our conversions there. And there's all sorts of information online to help you make those, additions, those alcohol or sugar additions to increase your alcohol. Here is the tool that we typically use to measure our titratable acidity in wine. So we have here a sample, or our sample of wine over here. And this is a self-zeroing burette with a stopcock. And we're using sodium hydroxide at 0.1 molecular level. And what we would do then is take our sample and add a starch indicator to it. And this would then, down here we have a magnetic stirring machine with a magnetic stir bar. So the entire time that you're adding your sodium hydroxide, it will be mixing. At some point, the starch indicator and the wine will be neutralized basically at a certain pH level. And that's when we're going to have our color change in the wine from a clear sample to basically a light pink that stays for a while. And then you would measure how much sodium hydroxide you used to take the sample, and that would give you your measurement. And then there's also very many options to look online how to do the mathematical conversion there to wind up to get your grams per liter of how much titratable acidity you have in your wine. So this is a pH meter, and this is how you would want to sample your pH. I kind of tend towards Hanna instruments because they've always been very, very good, very accurate tools to measure pH. And you also want to get one you want to get calibration buffers with your pH meter so that you can always calibrate it and make sure that it's reading correctly. So I think you need a calibration buffer 4 pH and a calibration buffer 7 to be in the wine range. So you want a wine pH tester. That's very important. And this one is basically somewhere just over $100, if I'm not mistaken. It's a great little handy tool to have like that. So here is a visual indication of what you can do with those numbers once you've taken your sample and you have your number for total acidity in grams per liter, and you have your Brix content here. You can plot them out on a chart. Say you've taken 3 samples over a month. And if we have 3 different plotting levels, we'll see our total acidity is obviously starting to respirate. So we're dropping acidity, and we're increasing our sugar levels as the grapes ripen. They're going to be building more and more sugar. That's what we want them to do. And at this point, where total acidity and sugar meet is where you're going to start having your chemical ripeness. And beyond that, there are other indications for ripeness then. So that's that point there. Okay, so again, this is the ripeness based on chemical parameters. And once you go beyond this, you're going to start looking at other parameters for ripening. So we have, I put this kind of in 3 stages. You're looking at your chemical, which are the numbers that give you an indication, but you've also got to look at some physical attributes. And you've got to take into consideration, especially here where we're making wine, this is very important, your sensory, like the flavor, aroma, and texture. So those form of ripeness as well. So these are all kind of indications of what you would need to bear in mind. So let's start with the chemical. We have usually in muscadine Brix somewhere between 12 and 15. Then physically we can see that we have like yellow-green berries that start to turn bronze when they're ripened, and then they turn like a very dark brown and give a shrivelness almost to it when they are almost overripe. So for the sensory portion of this area, the berries will detach from their skins when you squeeze them and the inner pulp pops out. That should happen with just a small amount of resistance when the berries are ripe. It shouldn't take much force to squeeze them out. And there should be some juice there that pops out as well when you squeeze it. So then we look at our pH, of course, another chemical indicator. Now our physical indicator over here is going to be the berry resistance. As I discussed before, this is the berry color. The berry resistance would be, you would squeeze the berry, and if it was firm, it's still obviously not ripe. And if it becomes a bit elastic and softer to squeeze, then we're probably in that ripe phase. And then once we reach the shriveled phase, we're probably a little overripe there. So the pulp texture in our sensory area is going to be somewhat firm with very little juice yield when you squeeze the pulp out, and then to somewhat jelly-like with a high juice yield, excuse me. And then again, when they start to shrivel, it will be completely difficult to squeeze much of anything out, and you won't be able to very easily remove the slip skin either. So let's review our berry attachment. This is a great physical indicator because, say, if you were to just shake the canopy and the berries just sort of pop off the pedicel, that's an indication that they're nice and ripe. Obviously, that's one cool thing about muscadine, is that it kind of tells us when it's ready to go. Whereas if you had to really pull off of the stem there, then that's probably still going to be a pretty hard berry. And when you have like zero resistance, when you're like touching the canopy, or if somebody sneezes on it and all those berries fall off, then maybe you're a little overripe. And then we want to look at our flavor and take into consideration that, of course, the very unripe they're going to be a bit more bland with sharp acidic features, because again, our acidity is not ripe yet. But when they start to turn these beautiful tropical fruit aromas like pineapple, peach, and ripe pear, they're probably right there in the ripe area. Now, if we get more guava, overripe papaya, or a heavily foxy tone, we're more than likely a bit overripe. So, and then another indication, physical wise, is the seed color. If you pull the seeds out, or you chew a little bit on the pulp and then get us the seeds out so we can look at them, if they still have a bit of chartreuse, that like lime green color, then they're probably not quite ripe. But then once they start to turn this like nice brown color, they're good and ripe. And then they will turn a very dark brown color when it's overripe. And then the seed flavor, from unpleasant flavor when you're chewing on it to kind of a pleasant, almost nuttiness, almost crunchiness, then that tends to be in riper berries. Okay. So again, our ripening parameters on the chemistry side, and that pretty much sums it up. And I look forward to hearing from you. If you have any questions, I'd be glad to answer them for you. Thank you so much for your time. Thank you for listening, and enjoy the presentations.